Did you ever wonder why certain websites pop up at the top of your search results and others are lower down the page? Just how does Google sort out all of those websites into a list? In this lesson, you'll dive even deeper into lists to look at how they can be sorted in lots of different ways. Now that you know the basics of lists and you know how to populate a list and you can process that list, let's take a look at how we could sort the lists. For example, if you had a grocery list, kind of like the one that you see on the screen, and you wanted to sort it into alphabetical order, or maybe some other kind of order, you would certainly want to have a way to, an algorithm in mind to explain to your computer what it would mean to get this list into alphabetical order. Because remember, these words have no meaning for the computer whatsoever. All they are is a series of little ASCII codes or maybe Unicode codes that indicate which little teeny tiny switches are on or off in the processor. So that's a pretty tall order for a computer to understand why apple should come before spinach. Right? So this is really one of the most iconic problems that is studied in computer science in terms of programming and algorithm development. You may remember there was a famous quote by President Obama. Somebody had asked him, being facetious, I believe, about his preferred sorting algorithm or which algorithm would be the best to sort some sort of list. And his response was bubble sort, which is a particular sorting algorithm. If President Obama knew about sorting, then that's a pretty good indication that this is kind of a big deal in computer science. All right, so let's talk a little bit more about this. Sometimes the order of a list isn't important. Maybe if you're seeking input from your user and it's a list of user names for people who played a game, you want the names to just be in the order that they were received. It doesn't really matter if you want them in alphabetical order or something like that. But sometimes we do. For example, in the dictionary, or when your teacher sees you or learns your name for the first time, it's from the sheet that they get that has everybody's name and student ID number, and you're sorted alphabetically. This is a really common task for lists, is to reorder them in some way that makes them more meaningful or easier to use or something like that. At the core of this issue, something that's involved in this, a term that's involved in having the flexibility to reorder a list is swapping. You're familiar with the term swap. We think of it as a trade, like, oh, I'll swap you my bag of Doritos for your Oreos or something like that, right? So we kind of think it in terms of a trade. In the way that swapping applies to reordering a list, we need to think of what is being traded. What is being traded out for what? And how exactly does that happen? Because, you trade your Doritos for somebody's Oreos and you just kind of toss them across the lunch table or something like that. Boom, done. But it's a little more complicated when we're actually talking about a list. All right, so in this case, we might be talking about taking the first list item and swapping it or trading it, switching it with maybe the last. Sorting is a very well-studied topic in computer science, especially with the advent of search engines, because it's really important to people how their website sorts out when people search for it. When we're talking about swapping things out, it's described as a selection sort, all right? So there are a lot of different algorithms, and you can actually check out the link that's in the lesson. It goes to the Wikipedia page, and you'll find out just how many different sorting algorithms there are. Some of them are very, very creative, because sometimes this swapping method isn't the most efficient way to sort a list. But for us, it's the most intuitive. This is the way humans typically would manually alphabetize things, right? So we've established that in reordering a list and for a selection sort, that a swapping is involved, all right? Unfortunately, it's just not that simple. You didn't think it would be, right? With swapping, there comes a little bit of a problem, okay? Now, look at the table on your screen. All right, so if we're talking about swapping the values at positions X and Y. So X has 15, Y has 32. Well, ultimately what we want is we want for 32 to be with X and 15 to be with Y, right? All right, so how would you do this if this were text on your screen? Right? So if you had a table and you were typing in things on the table and you typed in two things and you realized you actually wanted to switch them, or cells on a spreadsheet, something like that, right? How would you do that? Okay, and let's think even a little more simply. Like, think about holding two books, and the book in your left hand is heavy. Your left hand is getting tired. Your right hand, the book in your right hand isn't as heavy. So what you want to do, your right hand is kind of fresh, your left hand is tired from holding the heavy book, and you want to switch them. You want to switch the book that's in your left hand over to your right hand, and your right hand back to your left hand. How do you do that? Are you going to throw both books up in the air at the same time and then try to catch them with the opposite hand? If you could do that, that would be really fantastic, and I'd be very proud of you. However, I know that I myself would have trouble with that. It would require a whole lot of luck and probably more skill than I have. All right, so that's a problem. All right, so we're standing here holding the book. Probably what you're going to want to do is you are going to have to put the heavy book in your left hand down. You're going to have to put it on the table or put it on the desk or something like that. Then take what's in your right hand, move it over to your left hand, and then pick the heavy book back up with your right hand, right? So you need a space to put that heavy book down if you're going to swap hands with which hand is holding which book. So on this table, we can see that doesn't necessarily work because we can't put down 15. Well, we can, but we would have to put it somewhere else, right? Because we can definitely take the number 15 and we can move it over to this spot right here. You can think of copying and pasting. I would copy the 15, I would go over here, I would paste it over the top of the 32, right? Well, that leaves us with this. Now, you're stuck remembering that Y was originally 32, okay? Well, guess what? Your computer doesn't have as good of a memory as you, okay? Because that 32 was written, saved on a particular set of switches, okay? They were set up exactly to hold the number 32. When you overwrote the value, that number 32 is gone. The computer does not remember it, okay? So that's a problem. Where did 32 go? Right? It's gone. So, remember when we talked about how you would have to put the book down so that you could move the book in your right hand over to your left hand? Well, here you go, okay? Here's your space to put that 15 down. All right, so what we would have wanted to do in this case is we would first probably want to take 32 and put it in the swap space over here, right? And once we've done that, then it's a simple matter of overwriting the value of X, okay? So X moved to Y, Y moved to swap space, and then swap space is going to come right over here and take the place of this 15, right? Okay? So that's how you need to think about swapping. We can't just overwrite something in the computer's memory without saving it somewhere else. Okay, because remember, the computer doesn't have as good a memory as you. If you don't tell that data to persist somewhere else, it will be gone. Using this line of logic, we can construct an algorithm for swapping two values. So now you know the concept, right? You can visualize the concept, and we just visualized it on the previous screen. However, remember, when you create an algorithm, you actually need to think about the step-by-step instructions. Okay, I know conceptually what needs to happen, but how do I tell the computer to make that happen? All right, so let's talk about what that algorithm might be. Okay, so here's our table. We're talking about X and Y, and instead of looking at particular numbers like 15 and 32, let's just use the values X and Y. All right, so you can see that in the top row, in our original order, column X contains value X and column Y contains value Y, right? And the goal is to swap those two. Okay, so I've got this empty space. I've got temp, right? Temp, I can set it to whatever I want to initially. Probably just an empty space is fine. You could set it to 0. You can set it to whatever you want. You can set it to the word tacos. The whole point of it is that something else is going to go there anyways, right? Okay, so here's our algorithm. We need to tell the computer exactly what to do because remember, the computer won't be able to quote unquote remember like we do that X originally contained X once we've overwritten it. All right, so let's go ahead and use our temp space right away. And let's move the value from Y, not move it necessarily, but let's go ahead and assign temp the value of Y. Okay, and that's this right here. So you can kind of recognize the AP style pseudocode. This is how they show assignment of a value. They're saying assign whatever value is in Y to the variable temp. All right, so that's our first step. Set temp to Y. All right, now that gives us 2 Ys. Okay, so we've got duplicate Ys right here. All right, definitely not what we want quite yet. All right, next step, step 2, is going to be to assign to Y the value that's currently in X. All right, so take the value that's currently in X and assign it to Y. There we go. Okay, well now instead of having 2 Ys, now we've got 2 X's. Okay, but that's interesting. Notice the Y is still here. It's in temp. We didn't forget that we had it. All right, so step 2, assign the value of X to Y. All right, and last but not least, we want to take whatever value is in temp, currently it's Y, the value that was originally in Y, and we want to assign it to spot X. Okay, so right here you can see a nice algorithm. This is just 3 assignment statements in a row, but what we're doing is we're assigning something into a blank space to be held temporarily so that when we overwrite it, it's not gone. Because at this step right here, if we would have overwritten the value in Y with whatever was in X, the value in Y would have been gone. Okay, but it wasn't because we held on to it in this temporary space. Okay, so just remember that, a 3-step assignment process, assigning 2 different values to 3 different variables. All right, and that way we can achieve the swap. Think of the temp as whatever the table or chair or desk that you had to set down that heavy book. You've got to put it somewhere so that we can move, copy the book over to the other hand. All right, and then pick up the value that was in temp. So where else do we see this reordering? All right, think of anything that you do on your phone. A lot of times you want to rearrange the way that the apps are arranged on your home screen. For example, you want to switch out apps that you don't use anymore to a different secondary or tertiary screen, and the apps that you use, you want to bring them onto your home page, right? So you're reordering the apps. When you're shopping online, sometimes you want to see by what's cheapest. You know, like right now I just need to worry about what's cheapest. Please sort by price, all right? And then you see all the cheapest items on top. And the most expensive items would be at the bottom of the list. Or you want to get the best reviews, right? So the product that has the best reviews, that's what I want to see at the top of my list. Sometimes you want to rotate an image. You want to do a mirror flip or something like that. So you want to swap sides. So all of these tasks are essentially reordering of list items so that they are displayed in a different way. We've output lists in different orders before now, but we haven't actually changed the list content so that they're stored in a different order. All right, so all of these things are reasons why we would want to do this. So in the lesson, you have access to a Scratch program and you can access the blocks. And we want to look and see, you know, what is going on here. Let's kind of take a look at this before we jump straight into Scratch. All right, so first of all, of course, we want to check for sequence. Down here we see a sequence of steps. And I don't want to give away the surprise ending or anything, but right here I do see a sequence of 3 assignment statements. So there are definitely sequences of blocks in here, and it looks like the sequence is probably important. The order is probably important. I do see some selection, all right? So it looks like right here I've got an if statement. So remember, the if statement without the else is only going to run. So this block here, right here, whatever this does, is only going to run if this Boolean is true right here. And if the Boolean is false, it's just going to skip to here and ignore it. Okay, and I do see some iteration. I actually see a couple examples of iteration. Here's a repeat length of words, which is a list, as you may have guessed. And also I see repeat until. It's a conditional loop. All right, so definitely we've got a combination of sequence, selection, and iteration. Now, how does it relate to sorting? Well, it all goes down, kind of boils down to the fact that there have been several variables created, and one of them is the equivalent to our temp. I don't know if you can see this on the screen. You can definitely see it in Scratch, but right here we have a variable called index of best so far. Okay, that's interesting, right? That's an interesting variable name. We have a variable called check here. Okay, and last but not least, I do want you to notice that we have a variable called swap space. All right, so there's our temp. All right, and what we're looking at is here's our index variable. We're very accustomed now in lists to creating an index variable. We know that the list already has an index, but we like to be able to keep track of it, and our index variable allows us to access different list items based on their index. All right, so we're going to set our index to 1, meaning it's starting with the first item on the list, and then it looks as if we're going to set these two variables also to whatever index happens to be. Okay, in here, it looks like we're going to do some sort of a mathematical comparison of between whatever item is in check here versus whatever item is in best so far. Okay, and so we're going to do a mathematical comparison of those two words, and if that mathematical comparison turns out true, we'll do this here, and if it's not, we'll ignore it and move on here. Okay, and then we have our 3 assignment statements right here that are going to apparently take values from the list and sort of achieve our swap, okay, like we talked about. All right, so at this point, we've kind of examined, kind of, thought ahead a little bit about what might be happening in our program. So let's take a look at how this actually works.